Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm here with Victor. Before we dive in, if you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. It really helps us reach more developers like you.
Thanks, Sheila. Today we're wrapping up Chapter 2, Fundamentals of P2P Networks. We've covered a lot of ground, and this summary will help solidify the key concepts we've discussed.
Absolutely, Victor. But before we jump into the summary, I've got a quiz question for our listeners. What popular file-sharing application, launched in 1999, is often credited with bringing P2P networks into mainstream awareness?
Ooh, that's a great question, Sheila. It really takes us back to the early days of P2P. I remember when this application came out, it completely changed how people thought about file sharing. But let's not give away any hints just yet. We'll reveal the answer at the end of the episode.
Good call, Victor. Now, let's start our summary by revisiting the concept of P2P systems. Can you give us a quick overview?
Certainly. Peer-to-peer P2P systems are decentralized networks where each node or peer acts as both a client and a server. This is in contrast to traditional client-server models where there's a clear distinction between service providers and consumers.
Right, and we talked about different P2P network topologies. I remember there were 3 main types. Can you remind our listeners what they were?
Of course, we discussed 3 main types of P2P network topologies: unstructured, structured, and hybrid networks. Unstructured networks are the simplest, where peers connect randomly. Structured networks use specific algorithms to organize peers, often using distributed hash tables, DHTs. Hybrid networks combine elements of both P2P and client-server models.
That's a great summary, Victor. You know, I've been thinking about an analogy that might help our listeners understand these topologies better. Imagine a neighborhood.
I love analogies. Go on, Sheila.
Well, an unstructured P2P network is like a neighborhood where everyone just talks to their immediate neighbors without any particular organization. A structured network is more like a planned community with a specific layout where you know exactly which house to go to for what you need. And a hybrid network? That's like a neighborhood with both houses and some central facilities like a community center.
That's an excellent analogy, Sheila. It really helps visualize the differences. Now, let's talk about some of the advantages of P2P networks that we covered.
Right. One of the biggest advantages we discussed was scalability. As more peers join the network, the overall capacity of the system increases. There's also improved fault tolerance since there's no single point of failure. What else stands out to you, Victor?
Great points, Sheila. I'd add that P2P networks often have lower operational costs since there's no need for powerful central servers. They also provide a level of anonymity and privacy that centralized systems can't match. However, it's important to note that these advantages come with their own set of challenges.
Absolutely. Can you remind our listeners about some of the challenges we discussed?
Certainly. Some key challenges include maintaining consistency across the network, dealing with churn as peers join and leave, and ensuring security against malicious peers. There's also the free rider problem, where some peers consume resources without contributing back to the network.
Those are important points, Victor. We also compared P2P networks to client-server architecture. What were some of the key differences?
The main difference is in how resources and responsibilities are distributed. In a client-server model, powerful central servers handle most of the work, while in P2P, these tasks are distributed among all peers. This leads to differences in scalability, fault tolerance, and control. Client-server systems are often easier to manage and secure, but they can be more expensive and less resilient to failures.
Excellent summary. Now, let's talk about some real-world applications of P2P networks. I think this is where things get really interesting for our listeners.
Absolutely. We've seen P2P networks used in file-sharing systems like BitTorrent, communication platforms like Skype, in its earlier versions, and even cryptocurrency networks like Bitcoin. Content delivery networks, CDNs, also often use P2P principles to improve efficiency.
Those are great examples, Victor. I think it's fascinating how P2P technologies have evolved and found applications in so many areas. Before we wrap up, is there anything else you think is crucial for our listeners to remember about P2P networks?
I think the key takeaway is that P2P networks represent a fundamental shift in how we think about distributing and accessing resources on the internet. They offer unique advantages in terms of scalability and resilience, but also come with their own set of challenges. As developers, understanding these principles is crucial as we move towards more decentralized systems.
Well said, Victor. Now, I think it's time to reveal the answer to our quiz question. The application that brought P2P into mainstream awareness in 1999 was Napster. This music-sharing platform revolutionized how people thought about file sharing and sparked numerous legal and ethical debates.
Absolutely right, Sheila. Napster was a game-changer that paved the way for many P2P applications we see today. It's a great example of how technology can disrupt entire industries.
Indeed it is. Well, that wraps up our summary of P2P networks. In our next chapter, we'll be diving into distributed hash tables, DHTs, which play a crucial role in many structured P2P networks. It's going to be exciting.
I can't wait, Sheila. DHTs are a fascinating topic that will help our listeners understand how large-scale P2P systems manage and locate data efficiently.
Absolutely. Before we go, we'd love to hear from you, our listeners. Visit crashcasts.com to join our Discord community, where you can discuss today's topic and connect with other developers interested in decentralized systems. And if you're finding value in our podcast, please consider supporting us on Patreon. Your support helps us continue creating this content for you. Until next time, happy coding.